The metallic screech of cutting torches pierced the humid Hawaiian air as workers descended into the oil-slicked hull of the USS Oklahoma, their headlamps cutting through absolute darkness. Bodies floated in the flooded compartments, some still clutching tools from routine maintenance, while others had been trapped in their bunks when 1,400 tons of seawater crashed through the ship's ruptured side. The stench of fuel oil mixed with decomposition hung heavy in the confined spaces, forcing salvage crews to work in 15-minute intervals before retreating to vomit over the side. Men who had never seen a dead body now pulled dozens from twisted steel corridors, their hands shaking as they tagged each sailor's remains. What began as America's darkest naval disaster would become its greatest industrial resurrection, but only through the relentless labor of 10,000 workers who transformed Pearl Harbor into a 24-hour factory of war. Would they rebuild the fleet fast enough to prevent a Japanese invasion of the American mainland? Within 6 hours of the attack, Navy Yard workers were already ankle-deep in oil-contaminated harbor water, their civilian clothes soaked as they began the impossible task of cataloging devastation. The first workers to reach the harbor's edge moved like sleepwalkers through a landscape transformed beyond recognition. Where gleaming white naval vessels had anchored in perfect formation that morning, twisted hulks of blackened steel now protruded from water, turned black with fuel oil. The USS Arizona's forward superstructure had vanished entirely, leaving only her aft mast visible above the surface like a tombstone marking her crew's grave. Nearby, the USS Oklahoma rested completely inverted, her massive hull creating an unnatural island where seabirds perched uncertainly on barnacle-covered steel that had never been meant to see daylight. Captain Claude Bloch, the Navy Yard superintendent, stood on the concrete pier surveying destruction that exceeded his worst nightmares. The attack had lasted less than 2 hours, but its aftermath would define every moment of his remaining career. Around him, civilian workers who had been enjoying Sunday morning coffee were now wading through debris fields where personal effects from destroyed ships floated alongside chunks of superstructure and unexploded ordnance. The sweet smell of burning fuel oil mixed with the acrid smoke from still smoldering aircraft, creating an atmosphere that burned the throat and eyes of anyone who breathed too deeply. The initial assessment revealed carnage that challenged every assumption about American naval power. The USS West Virginia had settled into the harbor mud with her deck awash, massive holes torn in her port side by torpedo impacts that had flooded her engineering spaces within minutes. The USS California listed heavily to port, her elegant lines distorted by the weight of thousands of tons of seawater that continued pouring through ruptured hull plates. Even ships that appeared intact bore invisible wounds. The USS Nevada, which had attempted to escape during the attack, sat beached near the harbor entrance with her bow compartments flooded and her forward magazines declared unsafe due to potential unexploded bombs lodged deep within her hull. Workers moved through this maritime graveyard with the methodical precision that would define the coming months. Salvage crews used makeshift rafts constructed from wooden pallets and empty fuel drums to navigate between the wrecks, their movements careful and deliberate as they mapped the extent of damage to each vessel. The water itself had become a hazardous environment where every surface was slick with petroleum products that created rainbow patterns across the harbor's surface. Men slipped frequently on oil-coated ladders and deck plates, their hands leaving dark prints on everything they touched as they worked to establish basic safety perimeters around each damaged ship. The human cost became apparent as rescue operations continued throughout the day. Bodies floated in compartments that had become death traps when Japanese torpedoes ruptured hull plates and flooded entire sections of ships within moments. Survivors emerged from damaged vessels covered in oil, their faces blackened and their voices hoarse from smoke inhalation. Many could barely speak coherently about what they had witnessed. Pharmacist's mate third class Joe George, one of the few survivors pulled from the Arizona's aft section, could only repeat that the forward magazines had exploded with such violence that men simply vanished in the blast, their bodies vaporized by temperatures that exceeded 3,000 degrees Fahrenheit. The scale of destruction defied every precedent in naval history. 18 ships had suffered significant damage, with 8 battleships bearing wounds that ranged from moderate to catastrophic. The USS Utah, serving as a target ship, had capsized completely and would remain a permanent monument to the attack. The USS Shaw's forward magazine had detonated during the raid, destroying her entire bow section and leaving photographers with images that would symbolize American vulnerability. Nearly 200 aircraft lay scattered across airfields in twisted heaps of aluminum and steel, their destruction so complete that salvage crews could barely identify aircraft types from the wreckage. Yet even as rescue operations continued, a different kind of work had already begun. Navy Yard engineers moved through the devastation with clipboards and measuring tools, their task not to mourn the destruction, but to calculate the possibilities for resurrection. Each damaged ship represented not just a loss, but a potential recovery, provided the right combination of engineering skill, industrial capacity, and human determination could be brought to bear. The battleships represented the Navy's most valuable assets, each one requiring years to construct and embodying decades of technological advancement. Replacing them through new construction would take 3 to 5 years per vessel, time that American forces in the Pacific could not afford. The magnitude defied comprehension. 8 battleships damaged beyond immediate repair, requiring 150,000 tons of water removal from flooded compartments, 2,000 from 403 American casualties demanding immediate medical attention and burial preparation, and an estimated 4.5 million gallons of fuel oil contaminating harbor waters that would need complete environmental remediation before salvage operations could safely commence. Captain Block issued orders that would transform Pearl Harbor from a scene of defeat into the foundation of America's Pacific resurgence. Salvage operations would begin immediately, not in weeks or months, but within hours of the last Japanese aircraft disappearing over the horizon. The Navy Yard's machine shops, relatively undamaged by the attack, would operate around the clock to manufacture specialized equipment for ship repairs that no peacetime facility had ever attempted. The harbor itself would be converted into the largest ship reconstruction facility in naval history, its every pier and dry dock dedicated to the systematic resurrection of American sea power. Workers who had arrived that morning as routine maintenance personnel now faced a mission that would consume the next 3 years of their lives. The ships scattered around them represented more than military hardware. They embodied the industrial might and technological supremacy that had defined American naval power since the turn of the century. Raising them from the harbor floor would require innovations in engineering, metallurgy, and logistics that would push every established boundary of what was considered possible in ship salvage operations. As darkness fell over Pearl Harbor on December 7th, the fires continued burning on the water's surface, casting dancing shadows across the faces of men who had witnessed the end of American naval dominance in the Pacific. Yet in the machine shops and planning offices that had escaped destruction, other men were already beginning the calculations that would determine whether those shadows represented permanent defeat or merely the darkness before an industrial dawn that would illuminate American determination in ways the world had never seen. By December 15th, engineers calculated that raising the sunken battleships would require moving 150,000 tons of water and mud from ship compartments, equivalent to emptying a 20-story building. The mathematics of resurrection began in a converted conference room where naval architects spread blueprints across tables still bearing coffee stains from the morning of December 7th. Captain Homer Wallen, the Navy's chief constructor who had arrived from Washington aboard the first available transport, stood before drawings that revealed the full scope of devastation in precise engineering terms. Each damaged battleship represented a unique puzzle of structural failure, flooding patterns, and metallurgical challenges that no peacetime manual had ever addressed. The USS West Virginia alone bore 45 separate torpedo and bomb impact sites, each requiring individual assessment before any comprehensive repair strategy could emerge. Wallen's team worked with slide rules and mechanical calculators to quantify problems that existed at the intersection of physics and catastrophe. The Oklahoma had rolled completely inverted, her 29,000-ton mass now resting upside down on the harbor bottom, with her superstructure buried deep in mud that had accumulated over decades of harbor operations. Traditional salvage methods involved patching holes and pumping out water, but the Oklahoma's position defied conventional approaches. Her gun turrets, each weighing over 1,400 tons, were now pointing directly into the harbor floor, creating anchor points that would resist any attempt to return the ship to an upright position. The West Virginia presented different but equally daunting challenges. Her hull had settled into the harbor mud with a slight list to port, but diving surveys revealed that the ship's internal structure had been compromised by the force of multiple torpedo impacts. Bulkheads designed to contain flooding in one compartment had buckled under pressure, allowing seawater to flow freely throughout the ship's interior spaces. The result was a vessel whose every compartment below the main deck was completely flooded, creating a waterlogged mass that weighed nearly twice her design displacement. Engineering surveys revealed damage patterns that challenged fundamental assumptions about battleship construction. The Nevada, which had attempted to escape during the attack, bore evidence of both torpedo and bomb impacts along her port side. A single bomb had penetrated her forward decks and exploded deep within the ship, destroying internal bulkheads and creating a crater that extended through multiple deck levels. The explosion had generated pressures sufficient to warp steel beams 6 inches out of true alignment, while the subsequent flooding had corroded electrical systems and mechanical equipment throughout the forward third of the vessel. Naval architects calculated that conventional repair methods would require 18 months per battleship, assuming optimal working conditions and unlimited resources. The West Virginia's damage assessment revealed over 300 individual hull breaches requiring patches, while her internal spaces contained an estimated 20,000 tons of contaminated seawater mixed with fuel oil, hydraulic fluid, and debris from destroyed equipment. Each ton of water would need to be pumped out before repair work could begin, but the pumping process itself required that hull breaches be sealed first to prevent immediate reflooding. The magnitude defied comprehension. 52,000 tons of steel would need cutting and replacement across all damaged vessels. 4.5 million gallons of contaminated fuel oil required removal from harbor waters. Salvage operations alone would consume an estimated 12 million man-hours of labor, and the Navy Yard's electrical capacity required a 400% increase to power continuous welding and pumping operations throughout the expanded facility. Wallen's most revolutionary insight emerged from studying the Oklahoma's seemingly hopeless position. Rather than attempting to raise the inverted battleship directly, his team proposed a controlled rotation that would gradually roll the vessel upright while simultaneously lifting her from the harbor bottom. The process would require installing 21 massive winches around Ford Island, each capable of generating 150 tons of pulling force through steel cables arranged in precise geometric patterns. The mathematical calculations involved vector analysis of forces that would act upon a 29,000-ton mass during a 150-degree rotation, with safety margins calculated to prevent cable failures that could kill dozens of workers. The technical solutions required innovations that pushed beyond established engineering practices. Underwater cutting operations would employ oxyhydrogen torches capable of functioning in flooded compartments, but the process generated explosive gases that required constant ventilation to prevent catastrophic accidents. Welding operations on ships partially submerged in seawater demanded specialized electrodes and techniques that could create watertight seals despite the presence of oil contamination and salt corrosion on all metal surfaces. The Nevada's reconstruction presented unique challenges related to unexploded ordnance embedded deep within her hull structure. Japanese bombs that had penetrated the ship's armored decks but failed to detonate remained potentially active months after the attack. Each unexploded device required careful removal by ordnance disposal. Teams before welding operations could safely commence in surrounding areas. The process involved painstaking excavation through twisted steel and concrete, with workers using hand tools to avoid creating sparks that might trigger delayed explosions. Logistical calculations revealed requirements that strained every aspect of Pearl Harbor's infrastructure. The salvage operations would consume 847,000 pounds of welding rod per month, requiring dedicated supply ships to transport materials from mainland production facilities. Freshwater consumption for drinking, washing, and industrial operations would reach 2.1 million gallons daily, necessitating the construction of new desalination plants and storage facilities. The harbor's electrical grid required complete reconstruction to handle welding equipment that operated continuously across 3 shifts, with backup generators positioned throughout the facility to prevent power failures that could delay critical operations. Wallen's team calculated that success would require transforming Pearl Harbor into an industrial facility unlike anything in naval history. The existing dry docks could accommodate routine maintenance on cruisers and destroyers, but battleship reconstruction demanded floating dry docks, heavy-lift cranes, and specialized equipment that would need to be manufactured specifically for salvage operations. The workforce requirements exceeded the entire population of skilled metal workers available in the Hawaiian Islands, necessitating recruitment shipyards already operating at capacity for new construction programs. The economic implications were staggering. Each battleship reconstruction would cost approximately $40 million, equivalent to building 3 new destroyers or funding construction of an entire aircraft carrier. Yet the strategic calculations were equally compelling. New battleship construction required 3 to 5 years from keel laying to commissioning, while salvaged vessels could potentially return to service within 18 months if sufficient resources were committed to their resurrection. As December 1941 drew to a close, Wallen's engineering assessments had transformed Pearl Harbor's disaster into America's most ambitious industrial undertaking. The sunken battleships would rise again, but only through the application of engineering innovations, industrial capacity, and human determination on a scale that would redefine what was considered possible in naval construction and repair operations. As December ended, construction crews worked by floodlight to erect temporary housing for incoming workers, the sound of hammering competing with the ongoing explosions from unexploded Japanese ordnance. The transformation of Pearl Harbor from naval base to industrial city began with bulldozers clearing debris from areas that had been pristine military grounds just weeks earlier. Construction foreman William Furlong supervised crews working around the clock. To prepare building sites, their progress measured not in days, but in hours, as each delay meant fewer ships available for Pacific operations. The existing infrastructure could barely accommodate the Navy Yard's peacetime workforce of 2,500 personnel, but emergency recruitment had already brought the number to nearly 4,000 by Christmas, with projections indicating a need for 10,000 workers within 6 months. Temporary barracks sprouted across every available acre of land, their plywood construction offering functionality over comfort in structures designed to house workers rather than coddle them. The buildings rose in geometric precision, arranged in company streets that mimicked military organization while accommodating civilian workers who had never experienced regimented living conditions. Each barracks measured 20 feet by 100 feet and housed 50 men on canvas cots arranged in 2 facing rows, with a narrow aisle down the center that barely allowed passage when workers were dressing for different shifts. The speed of construction required compromises that would define living conditions for the duration of the war. Foundations consisted of concrete pads poured directly onto leveled ground, with wooden frames assembled using standardized lumber shipped from Pacific Northwest mills, operating at maximum capacity. The walls were single-layer plywood with tar paper covering, providing minimal insulation against tropical storms that could turn the structures into echo chambers of wind and rain. Windows were simple openings covered with screens, while lighting came from bare bulbs strung on exposed wiring that snaked along the ceiling beams. Privacy became a luxury that few workers enjoyed in barracks designed for maximum occupancy rather than personal comfort. Personal belongings were stored in makeshift footlockers fashioned from wooden ammunition boxes, their military stenciling still visible beneath hastily applied coats of paint. Workers learned to sleep, despite constant noise from shift changes, with men arriving from 16-hour days while others prepared for night shifts that would last until dawn. The barracks developed their own rhythms, with informal hierarchies emerging based on trade skills, seniority, and the ability to adapt to communal living conditions that challenged men accustomed to private homes and family life. The mess hall operations required industrial-scale food service that transformed military dining from routine meal periods into continuous feeding operations. The main cafeteria operated on military time schedules that began serving breakfast at 04:30 hours for workers starting the day shift, continued through lunch service at 11:30 hours for the swing shift, and concluded with dinner at 17:30 hours before beginning the cycle again for night shift workers arriving at 2300 hours. The facility served 30,000 meals daily, requiring coordination between Navy commissary officers and civilian contractors who managed food procurement, preparation, and service for a population that exceeded most American cities. The magnitude defied comprehension. 847 new barrack structures erected within 90 days. Housing capacity expanded from 1,200 to 8,500 workers. 67 miles of electrical wiring installed for lighting and power distribution. 14,000 individual work orders processed weekly for facility construction and maintenance. and 2.1 million gallons of fresh water required daily for drinking, washing, and industrial operations across the expanded facility. Kitchen operations functioned like military campaigns, with Filipino cooks working 18-hour shifts to maintain continuous food service for workers whose schedules defied normal meal patterns. The cooks had been recruited from civilian restaurants and hotels throughout Honolulu. Their peacetime experience with large-scale food preparation proving essential for feeding a workforce that consumed calories at rates typically associated with heavy construction or combat operations. Menus were necessarily simple and repetitive, featuring foods that could be prepared in large quantities and served efficiently to workers who often had only 20 minutes between shifts to consume their meals. The dining experience reflected the utilitarian approach that governed all aspects of worker life at Pearl Harbor. Long wooden tables with bench seating accommodated 12 workers each, with metal trays and utensils that could withstand constant use and industrial washing. The noise level during peak dining periods made conversation difficult, as hundreds of workers ate simultaneously while discussing shift assignments, overtime opportunities, and news from the war zones where their repaired ships would soon operate. Housing assignments followed a complex system that balanced trade specialization with shift schedules and work crew organization. Welders were grouped together to minimize disruption from varying work schedules, while heavy equipment operators shared barracks with crane operators and other workers whose shifts aligned with major salvage operations. The system created informal professional communities within the larger worker population, with trade skills determining social hierarchies that transcended traditional civilian class distinctions. Personal hygiene facilities reflected the same practical approach that governed all construction decisions. Communal shower houses featured multiple shower heads with minimal privacy barriers, designed for efficiency rather than comfort, as workers cleaned off industrial grime, oil contamination, and salt spray from harbor operations. Hot water was available only during designated hours, requiring workers to coordinate their schedules around facility limitations that emphasized water conservation and energy efficiency. Laundry operations became major logistical undertakings, with industrial washing machines running continuously to handle work clothes contaminated with oil, metal filings, and chemical residues from ship repair operations. Workers learned to maintain minimal wardrobes of work clothing while preserving civilian clothes for rare off-duty periods when they could visit Honolulu or write letters to families on the mainland who were following war news through newspapers that rarely mentioned the industrial resurrection occurring at dynamics within the barracks, reflected the diversity of backgrounds among workers recruited from across the United States. Shipyard workers from East Coast naval facilities shared living space with construction workers from California, welders from Texas oil refineries, and local Hawaiian workers who found themselves outnumbered by mainland transplants in their own homeland. These men brought different work traditions, regional dialects, and cultural expectations that had to be reconciled within the confined space of barracks life, where personal conflicts could disrupt entire work crews. As 1942 began, Pearl Harbor had evolved into a company town where the company was the United States Navy, and the product was American naval supremacy in the Pacific. The temporary barracks represented more than emergency housing. They embodied America's commitment to transforming industrial capacity into military victory through the systematic application of human labor on a scale that would define the character of American war production throughout the conflict. Diving crews descended into the Oklahoma's flooded interior, armed with pneumatic tools and body bags, their work illuminated only by waterproof flashlights that revealed horrors no training had prepared them for. The most dangerous assignment at Pearl Harbor fell to the salvage divers who entered compartments that had become underwater tombs when the Oklahoma capsized during the attack. Edward Raymer, a Navy diver with the salvage unit, led teams into the inverted battleship's hull, where darkness was absolute and every surface was coated with fuel oil that made movement treacherous and breathing difficult, even with diving apparatus. The ship's interior had become a maze of twisted metal, floating debris, and human remains that had been trapped when the vessel rolled over in less than 12 minutes during the Japanese attack. Working conditions inside the Oklahoma defied every safety protocol established for underwater operations. The ship's compartments were filled with a toxic mixture of seawater, fuel oil, hydraulic fluid, and decomposing organic matter that created an environment where visibility was measured in inches rather than feet. Divers navigated by touch through corridors that had been turned upside down, where ceilings had become floors and doorways opened onto spaces that no longer connected to their original layouts. The psychological challenge of working in complete darkness while surrounded by evidence of violent death proved as demanding as the physical dangers of the work itself. The diving teams encountered sailors who had survived the initial torpedo impacts, only to drown in the rising water as the ship capsized. Many bodies were found in positions that suggested desperate attempts to reach escape routes that had been blocked by debris or twisted beyond recognition when the massive vessel overturned. Personal effects floated throughout the compartments, creating an underwater museum of interrupted lives, where family photographs, letters from home, and service medals drifted among the structural wreckage of what had been the Navy's most powerful battleship. Raymer's crews developed specialized techniques for working in the contaminated environment, using communication systems that allowed constant contact with surface supervisors who monitored air quality and diving safety protocols. The work required precise coordination between divers inside the hull and crane operators above who lifted debris through openings cut in the ship's bottom, which was now the highest accessible point of the inverted vessel. Each piece of equipment or structural debris had to be cataloged before removal to ensure that nothing valuable to the salvage operation was lost in the process of clearing the ship's interior. The psychological toll on diving personnel became apparent within weeks of beginning operations inside the Oklahoma. Several experienced divers requested transfers to other duties after encountering compartments where entire gun crews had been trapped when the ship rolled over. The intimate nature of the work, requiring divers to handle human remains while performing technical tasks in extreme conditions, created stress reactions that Navy medical personnel were unprepared to address. Some divers developed drinking problems as a means of coping with nightmares that featured the faces of sailors they had recovered from the ship's flooded compartments. The technical challenges of working inside the inverted battleship required innovations in diving equipment and procedures that pushed beyond established Navy protocols. Standard diving suits proved inadequate for work in the contaminated environment, leading to the development of specialized protective equipment that could resist oil contamination while providing reliable air supply systems. The ship's interior spaces were so restricted that conventional diving equipment often prevented access to critical areas, forcing teams to modify their gear for work in spaces designed for sailors in normal conditions rather than divers in emergency equipment. The magnitude defied comprehension. 429 bodies recovered from the Oklahoma's interior compartments during salvage operations, 150,000 tons of contaminated water, and debris pumped from flooded compartments across all damaged ships, 67 individual diving operations required to clear each major compartment section, and 8,500 hours of underwater work completed before hull raising operations could commence. body recovery operations followed strict protocols that balanced respect for the dead with the practical requirements of ship salvage. Each sailor's remains were carefully documented and prepared for burial with full military honors, while personal effects were cataloged and returned to families when possible. The process required diving teams to work with mortuary personnel who had been trained to handle mass casualties but had never operated in underwater environments where decomposition was accelerated by the tropical climate and contaminated water conditions. The Oklahoma's gun turrets presented unique challenges for diving operations, as these massive structures had been driven deep into the harbor mud when the ship capsized. Each turret weighed over 1,400 tons and contained complex mechanical systems that had been twisted beyond recognition by the force of impact with the harbor bottom. Divers working inside the turret spaces encountered evidence of the crew's final moments, including battle stations logs that had been maintained until the ship's communication systems failed during the capsizing process. The salvage diving operations required constant coordination with ordnance disposal teams who worked to remove unexploded Japanese bombs and torpedoes that remained embedded in the ship's structure. Several bombs had penetrated the Oklahoma's hull but failed to detonate, creating explosive hazards that could kill diving crews if disturbed during salvage operations. The ordnance disposal work required specialized training that few Navy personnel possessed, leading to recruitment of civilian experts who had experience with industrial explosives but had never worked underwater. Diving crews also recovered valuable intelligence materials from the Oklahoma's interior, including code books, communication equipment, and operational documents that had been preserved in waterproof compartments. This material provided insight into Japanese attack methods and helped Navy intelligence officers understand the effectiveness of enemy weapon systems against American battleship construction. The recovery of technical manuals and engineering drawings also proved essential for planning the ship's eventual reconstruction once the hull could be raised and returned to dry dock. The work inside the Oklahoma continued for months as diving crews systematically cleared each compartment of debris, bodies, and equipment that could be salvaged for use on other ships. The process required meticulous attention to detail, as every piece of machinery removed from the ship had to be evaluated for potential reuse in the massive repair operations occurring throughout Pearl Harbor. Brass fittings, electrical components that had survived the attack intact, became valuable resources for reconstruction work on other damaged vessels. As the diving operations progressed, the Oklahoma's interior spaces gradually transformed from a scene of death and destruction into a cleaned hull ready for the engineering challenge of returning the massive vessel to an upright position. The diving crews had accomplished the most gruesome and psychologically demanding work required for the ship's resurrection, clearing the way for the mechanical operations that would eventually restore the battleship to the surface of Pearl Harbor, where she had once dominated the harbor's skyline as a symbol of American naval power. At 2300 hours, when most of America slept peacefully, Pearl Harbor's floodlights illuminated a scene of industrial frenzy as the graveyard shift began their race against time. The transformation of Pearl Harbor into a 24-hour industrial complex required a complete reimagining of how naval facilities operated during wartime conditions. Captain Claude Bloch had authorized continuous operations that divided the workforce into 3 8-hour shifts. Though most workers regularly exceeded their scheduled hours, as the urgency of ship repairs demanded flexibility that peacetime regulations had never contemplated. The day shift handled the heaviest lifting operations and major structural work that required maximum visibility, while the swing shift focused on precision welding and electrical repairs that could be performed under artificial lighting conditions. The graveyard shift inherited the most dangerous operations that couldn't risk civilian observation or interference from other work crews. Between midnight and dawn, teams removed unexploded Japanese ordnance from ship compartments, conducted underwater cutting operations that generated explosive gases, and performed heavy crane movements that required clear airspace around the harbor's damaged vessels. These operations demanded workers who could function effectively despite sleep deprivation, work in near-total darkness, and maintain concentration during tasks where momentary lapses could result in catastrophic accidents. The machine shops operated with a continuous rhythm that never acknowledged the difference between day and night. Chief Machinist Daniel Callahan supervised operations that ran lathes, drill presses, and milling machines around the clock to manufacture specialized parts for ship repairs that couldn't be ordered from civilian suppliers. The shops produced everything from custom hull patches to replacement machinery components, with specifications determined by damage assessments that changed daily as salvage operations revealed new problems requiring immediate solutions. Sleep became a luxury that few workers could afford as the pressure to accelerate ship repairs intensified throughout the winter of 1942. Welders learned to catch brief rest periods on benches between jobs, while apprentices maintained their equipment and prepared materials for the next operation. The barracks developed an informal culture where workers arriving from 16-hour shifts shared bunks with those leaving for different assignments, maximizing the use of limited sleeping accommodations while ensuring that skilled personnel remained available for emergency repairs that couldn't wait for normal shift changes. The mess halls evolved into continuous feeding operations that served workers according to industrial schedules rather than traditional meal patterns. Filipino cooks worked from 0300 to midnight, preparing food for workers whose caloric requirements exceeded those of normal industrial labor due to the physical demands of heavy lifting, welding in extreme heat, and diving operations that burned energy at rates comparable to combat conditions. The kitchen staff learned to prepare meals that could be consumed quickly by workers who often had only 20 minutes between shifts to eat before returning to operations that couldn't be interrupted. The magnitude defied comprehension. 847,000 pounds of welding rod consumed monthly across 3 shifts. 2.1 million gallons of fresh water required daily for drinking, washing, and industrial operations. 14,000 individual work orders processed weekly for ongoing repair projects, and 67 miles of electrical cable installed to power equipment operating continuously throughout the expanded facility. The night shift developed its own distinct culture within the larger worker community, with personnel who specialized in operations that required darkness or minimal interference from daytime activities. Crane operators who moved heavy equipment during graveyard hours worked with precision that came from months of practice in handling multi-ton hull sections and machinery components in near-total darkness. Their operations were guided by hand signals and radio communication that allowed coordination between ground crews and operators working 100 feet above the harbor surface. Welding operations continued throughout the night with teams that had adapted to working in confined spaces where artificial lighting created harsh shadows and extreme temperature variations. The welders developed techniques for maintaining consistent quality despite fatigue that accumulated over weeks of 12 to 16-hour shifts. Their work required constant attention to detail, as improper welds on critical hull repairs could result in catastrophic flooding when the repaired ships returned to combat operations in the Pacific. The electrical repair crews worked primarily during night hours when power demands from other operations were reduced, allowing them to shut down sections of the harbor's power grid for major repairs and upgrades. These workers had been recruited from civilian power companies and electrical contractors throughout the United States, their expertise essential for installing the electrical systems required to power continuous welding operations, pumping equipment, and lighting systems that kept the facility operational around the clock. Security operations during the night shift required constant vigilance against potential sabotage attempts, as the facility's strategic importance made it a target for enemy agents or sympathizers who might attempt to disrupt repair operations. Military police patrols coordinated with civilian security personnel to monitor access points, verify worker identification, and investigate any unusual activities that might threaten the ships or equipment, essential for Pacific Fleet operations. The harbor itself became a different environment during night operations, with navigation lights marking safe channels between damaged ships, while underwater cutting crews worked to remove debris that posed hazards to vessel movement. The water remained contaminated with fuel oil that created fire hazards during welding operations, requiring constant monitoring by safety teams who used specialized equipment to detect explosive gas concentrations that could ignite without warning. Communication systems operated continuously to coordinate activities between the three shifts, with supervisors maintaining detailed logs of work completed, problems encountered, and priorities for the following shift. The complexity of ship repair operations required precise documentation to ensure that work crews didn't duplicate efforts or compromise repairs begun by previous shifts. Radio communication systems connected work sites throughout the harbor with central coordination offices that tracked the progress of hundreds of simultaneous repair operations. The psychological demands of continuous operations created stress reactions among workers who found it difficult to maintain normal sleep patterns while adapting to shift work that rotated frequently based on operational requirements. Some workers developed chronic insomnia, while others struggled with depression caused by isolation from normal social rhythms and limited contact with families on the mainland. The Navy's medical personnel were unprepared for the mental health challenges created by sustained industrial operations under wartime pressure. Graveyard shift workers developed informal support networks that helped individuals cope with the physical and psychological demands of their assignments. Veterans of civilian shipyard operations provided guidance for workers who had never experienced industrial labor, while local Hawaiian employees helped mainland transplants adapt to tropical working conditions that posed unique challenges for men accustomed to temperate climates. As dawn approached each morning, the night shift personnel prepared detailed reports for their relief crews, documenting progress on repair operations that would continue seamlessly into the next work period. The continuous nature of the work meant that Pearl Harbor never truly slept, its lights visible from miles away as a beacon of American industrial determination to restore naval supremacy in the Pacific through the systematic application of human labor and engineering expertise that operated without regard for traditional limitations of time or endurance. When women first entered the USS Nevada's engine room with welding torches, the ship's surviving crew members watched in stunned silence as they began repairing damage that male workers had deemed nearly impossible to fix. The integration of women into Pearl Harbor's industrial workforce occurred gradually and with considerable resistance from military supervisors who had never contemplated female workers in naval shipyards. The acute labor shortage following America's entry into the war forced Navy officials to reconsider peacetime restrictions that had limited women to clerical positions and light assembly work. By early 1942, The demands of continuous ship repair operations required skilled workers regardless of gender, leading to the recruitment of women with technical training from mainland defense plants and local vocational schools. The first women to work on damaged battleships faced skepticism that extended beyond simple prejudice to genuine concerns about their physical capabilities in an environment designed around male strength and endurance. Welding operations required workers to manipulate heavy equipment while wearing protective gear that could weigh over 30 pounds, and the confined spaces within ship compartments demanded the ability to work in cramped positions for extended periods. Many male supervisors doubted that women could perform effectively under these conditions, while maintaining the quality standards essential for repairs that would face combat conditions in the Pacific. However, women workers quickly demonstrated advantages that male supervisors had not anticipated, particularly in precision work that required attention to detail and manual dexterity rather than brute strength. Female welders often produced higher quality work in the confined spaces within ship hulls, where their typically smaller stature allowed access to areas that were difficult or impossible for larger male workers to reach. The intricate electrical repairs required for restoring ship communication and fire control systems proved especially well suited to women who had previously worked in electronics manufacturing or telephone company installations. The social dynamics within the shipyard reflected broader tensions about women's roles in American society during wartime. Many male workers initially viewed female colleagues as temporary replacements who would return to traditional domestic roles once the war ended and normal gender hierarchies could be restored. This attitude created workplace tensions that supervisors had to navigate carefully to maintain productivity while integrating workers whose presence challenged established cultural assumptions about appropriate work for women. Women working at Pearl Harbor faced discrimination that was both overt and subtle, ranging from exclusion from informal work crews to assignment of the most dangerous tasks that male workers preferred to avoid. Some supervisors deliberately assigned women to work in areas contaminated with asbestos or toxic chemicals, assuming that concerns about long-term health effects were less important for workers who would presumably leave the workforce after the war. These practices reflected attitudes that viewed women as expendable temporary labor, rather than skilled professionals whose contributions were essential to the success of ship repair operations. The magnitude defied comprehension. 847 women employed at Pearl Harbor Naval Yard by mid-1942, representing 8.4% of the total workforce, 67% assigned to welding and electrical repair operations, 156 women working directly inside damaged ship hulls, and 23 women certified for underwater cutting operations that required specialized training typically reserved for male divers. The technical challenges of ship repair work proved that gender was less relevant than skill and determination in completing the complex operations required to return battleships to combat readiness. Women working on the USS California's electrical systems demonstrated exceptional proficiency in tracing damaged circuits through miles of wiring that had been corroded by seawater and contaminated with fuel oil. Their systematic approach to electrical repairs often exceeded the quality achieved by male workers, who relied more on experience than methodical analysis of circuit diagrams and technical specifications. The welding operations inside damaged ship hulls required workers who could maintain concentration while working in extreme heat and poor ventilation conditions that challenged physical endurance regardless of gender. Women welders developed techniques that emphasized precision over speed, creating joints that consistently passed quality inspections while requiring less rework than repairs completed by male workers who sometimes prioritized productivity over technical accuracy. These quality differences became particularly important for hull repairs that would face combat stresses where weld failures could result in catastrophic flooding. The integration of women into previously all-male work crews created opportunities for improved safety practices and workplace organization that benefited all workers. Female employees often insisted on better ventilation systems and safety equipment that male workers had previously accepted as unavoidable hazards of shipyard work. Their presence also encouraged supervisors to implement formal safety training programs and establish clear protocols for hazardous operations that had previously relied on informal knowledge transfer between experienced workers. Housing arrangements for female workers required modifications to the barrack system that had been designed exclusively for male occupancy. Separate facilities were constructed with improved privacy provisions and security measures that reflected concerns about the safety of women working in an overwhelmingly male environment. These accommodations were generally superior to the standard worker housing, creating some resentment among male workers who interpreted the better conditions as evidence that women received preferential treatment despite performing similar work under comparable conditions. The mess hall operations adapted to serve a more diverse workforce with dietary preferences and nutritional needs that differed from the standard military rations designed for male soldiers and sailors. Female workers often requested lighter meals that could be consumed quickly during brief breaks between shifts, leading to menu modifications that ultimately improved food service for all workers. The integration also led to improved sanitation standards and food preparation practices, as supervisors recognized that workplace efficiency depended on maintaining the health of all personnel, regardless of gender. The social relationships that developed between male and female workers ranged from professional collaboration to romantic attachments that complicated workplace dynamics and challenged military regulations about fraternization. Some work crews developed effective partnerships where gender differences became assets rather than obstacles, with mixed teams often outperforming single-gender crews on complex repair operations that required diverse skills and perspectives. The contributions of women workers at Pearl Harbor extended beyond their immediate technical accomplishment. The potential for expanded female participation in industrial operations throughout the American defense establishment. Their success in performing demanding physical labor under hazardous conditions provided evidence that gender restrictions in many occupations were based on cultural assumptions rather than practical limitations. This experience contributed to broader social changes that would reshape American labor practices and gender roles in the post-war period, as ship repair operations intensified throughout 1942. Women workers became integral to the success of salvage operations that returned the Pacific Fleet to combat readiness ahead of the schedules that had been considered optimistic when only male workers were available. Their presence at Pearl Harbor represented a permanent change in American naval operations, establishing precedents for female participation in military support roles that would expand throughout the war and influence post-war policies regarding women in the armed services and defense industries. At exactly 10:47 hours on March 8, 1943, the USS Oklahoma's massive hull broke the surface of Pearl Harbor for the first time since December 7th, seawater cascading from her barnacle-encrusted sides as winches strained against 29,000 tons of dead weight. The resurrection of the USS Oklahoma represented the pinnacle of salvage engineering, a mathematical marvel that required 15 months of preparation before the first cable could be attached to her inverted hull. Captain Homer Wallen's team had installed 21 massive winches around Ford Island, each one capable of generating 150 tons of pulling force through steel cables arranged in geometric patterns, calculated to distribute stress evenly across the battleship's hull structure. The winches themselves weighed over 50 tons each and required concrete foundations extending 20 feet into bedrock to prevent the tremendous forces from shifting their positions during the lifting operation. The engineering calculations for the Oklahoma's rotation had consumed months of work by naval architects who were attempting something that had never been tried in maritime history. The ship had to be rotated 150 degrees while simultaneously being lifted from the harbor bottom, a process that required precise coordination between all 21 winch operators working in perfect synchronization. A single miscalculation could snap cables under tension, equivalent to supporting a 20-story building, potentially killing dozens of workers and destroying equipment that had taken months to fabricate and install. The morning of March 8th found Pearl Harbor's entire workforce gathered along the shoreline to witness an operation that would either vindicate months of preparation or demonstrate the impossibility of raising a completely capsized battleship. Edward Raymer, the Navy diver who had spent months clearing bodies and debris from the Oklahoma's interior, watched from a salvage barge as winch operators received their final instructions through radio communications that connected every position around Ford Island. The tension was palpable among workers who had invested over a year of their lives in preparing for this single moment. The initial lifting phase began slowly, with winch operators applying tension gradually to avoid shock loading that could snap cables or shift the ship's position unpredictably. The Oklahoma had been resting on the harbor bottom for 15 months, during which time marine growth had accumulated on her hull and sediment had packed around her superstructure. The first indication of movement came not from visual observation, but from strain gauges that detected minute changes in cable tension as the ship began to respond to the lifting forces. As the hull began to move, seawater cascaded from openings that had been sealed underwater, creating waterfalls that caught the morning sunlight and created rainbow effects across the harbor surface. The Oklahoma's starboard side emerged first, revealing hull plating that had been corroded by prolonged submersion in salt water, contaminated with fuel oil and industrial chemicals. Barnacles and marine growth covered every surface, transforming the once pristine battleship into something that resembled an archaeological artifact recovered from the ocean floor. The magnitude defied comprehension. 21 winches generating a combined lifting force of 3,150 tons, 150-degree rotation accomplished over 6 hours and 23 minutes, 29,000 tons of ship and trapped water lifted from the harbor bottom, and 347 individual cable connections required to distribute stress across the hull structure without causing catastrophic structural failure. The rotation process required constant adjustment of cable tensions as the ship's center of gravity shifted during the lifting operation. Wallen's engineering team had calculated that the Oklahoma's weight distribution would change dramatically as seawater drained from compartments that had been sealed during the diving operations. The ship's massive gun turrets, each weighing over 1,400 tons, acted as pendulums that could destabilize the entire operation if their movement wasn't controlled through precise cable positioning. Spectators watched in fascination as the Oklahoma's superstructure gradually emerged from the harbor, revealing damage that had been hidden underwater for over a year. The ship's forward mast appeared first, followed by the bridge, structure that had been crushed when the battleship capsized during the Japanese attack. The conning tower emerged bent at an impossible angle, its steel plating twisted by forces that had been generated when 29 tons of battleship rolled over in less than 12 minutes. The most dramatic moment came when the Oklahoma's main deck broke the surface, revealing the full extent of destruction caused by the Pearl Harbor attack. Torpedo damage along the port side had created holes large enough to drive automobiles through, while bomb impacts had left craters in the deck plating that extended through multiple levels of the ship's interior. The wooden deck planking had been stripped away by marine organisms, leaving only the steel substructure that gave the ship its fundamental strength. Workers aboard salvage barges moved quickly to secure the Oklahoma in her new position, as the winches maintained tension to prevent the ship from settling back into the harbor mud. Pumping operations began immediately to remove seawater from compartments that were now accessible from above, while diving crews prepared to enter spaces that had been inaccessible during the previous 15 months of preparation. The ship's resurrection marked the beginning of a new phase in salvage operations rather than their conclusion. The Oklahoma's emergence revealed structural damage that exceeded even the most pessimistic engineering assessments. The ship's hull had been compressed by the weight of her own superstructure during the months on the harbor bottom, creating deformations that would require complete reconstruction of entire sections. The port side, which had taken the torpedo impacts during the attack, showed compression damage where hull plates had been driven inward by forces that no peacetime construction had ever contemplated. Cutting crews were aboard the ship within hours of her resurrection, beginning the systematic process of removing equipment and materials that could be salvaged for use on other vessels under repair. The Oklahoma would never return to service as a combatant, but her resurrection served multiple purposes beyond simple salvage value. The successful lifting operation demonstrated American industrial capability and engineering expertise that Japanese military planners had underestimated when they attacked Pearl Harbor. The psychological impact of the Oklahoma's resurrection extended far beyond Pearl Harbor to American military personnel throughout the Pacific who had witnessed the apparent destruction of the battle fleet. Photographs of emergence were distributed through military publications and newsreels that reached American audiences hungry for evidence that the December 7th attack had not permanently crippled American naval power. The Oklahoma's return to the surface represented symbolic victory over the forces that had attempted to destroy American military capability. As evening fell on March 8th, the Oklahoma sat upright in Pearl Harbor for the first time since the attack, her hull scarred but no longer hidden beneath the waters that had concealed the full extent of American determination to reverse the damage inflicted by enemy action. The successful lifting operation had required innovations in engineering, coordination, and industrial organization that would influence salvage operations throughout the remainder of the war, establishing precedents for ship recovery that extended far beyond the specific circumstances of Pearl Harbor. On February 12, 1942, the USS Nevada fired her main guns for the first time since the attack, the thunderous blast echoing across Pearl Harbor as proof that American battleships could indeed rise from their own ashes. The Nevada's resurrection from near-total destruction represented the most complete reconstruction project undertaken at Pearl Harbor, transforming a ship that had been declared a constructive total loss into a vessel superior to her original configuration. The battleship had suffered catastrophic damage during her attempt to escape the harbor during the Japanese attack, taking multiple torpedo hits along her port side, while a massive bomb penetrated her forward decks and exploded deep within her hull structure. The resulting fires had burned for 3 days, consuming everything combustible within the ship's forward sections and warping steel beams throughout her superstructure. Captain Homer Wallen's assessment team had initially recommended that the Nevada be stripped for parts and her hull used as a breakwater, but the strategic requirements of the Pacific War demanded that every serviceable battleship be returned to combat operations, regardless of reconstruction costs. The decision to rebuild, rather than scrap the Nevada, committed Pearl Harbor's workforce to a project that would consume more resources than constructing an entirely new vessel, but would deliver a battleship to the Pacific Fleet in 18 months, rather than the 4 years required for new construction. The reconstruction began with complete removal of the Nevada's superstructure, a process that required cutting away twisted steel that had been fused by temperatures exceeding 2,000 degrees Fahrenheit. Salvage crews used oxyacetylene torches to systematically dismantle everything above the main deck, creating a hull that resembled an empty steel box rather than a warship. The cutting operations generated sparks that posed constant fire hazards in compartments still contaminated with fuel oil, requiring fire watches and emergency response teams positioned throughout the work areas. The Nevada's forward magazine had been completely destroyed by the bomb explosion, leaving a crater that extended through 4 deck levels and required reconstruction of the ship's entire forward structure. Naval architects designed a new magazine system that incorporated lessons learned from combat damage reports throughout the Pacific, installing improved ammunition handling systems and enhanced fire suppression equipment that exceeded the specifications of the ship's original construction. The reconstruction essentially created a new ship within the Nevada's existing hull, incorporating technological improvements that reflected 2 years of wartime experience. The hull repairs alone required fabrication of over 400 individual steel plates, each one custom-fitted to match the Nevada's complex curves and structural requirements. The Pearl Harbor machine shops operated around the clock to produce hull sections that were then lifted by crane and welded into position by teams working in confined spaces where temperatures regularly exceeded 120 degrees Fahrenheit. The welding operations consumed enormous quantities of materials and electrical power, with individual seams requiring multiple passes to achieve the strength necessary for combat operations. The magnitude defied comprehension. 8.5 million man-hours invested in the year, Nevada's reconstruction, 347 tons of new steel fabricated for hull and superstructure repairs, 2,847 workers who carved their signatures into the ship's reconstructed sections, and 156 major equipment installations completed to modern specifications that exceeded the ship's original capabilities. The Nevada's propulsion system required complete rebuilding after seawater contamination had corroded her boilers, turbines, and auxiliary machinery beyond repair. The ship's engine rooms had been flooded for weeks before pumping operations could begin, allowing salt water to destroy precision-machined components that had originally been manufactured by specialized industrial facilities on the mainland. Pearl Harbor's machinists fabricated replacement parts using blueprints and specifications that had to be recreated from memory and examination of similar equipment on other ships. The reconstruction incorporated modern fire control systems that transformed the Nevada's gunnery capabilities beyond her original design specifications. The new equipment included radar-directed gun-laying systems that allowed accurate firing at targets beyond visual range, a capability that would prove essential in the long-range naval engagements that characterized Pacific combat operations. The installation required extensive modifications to the ship's electrical systems and structural arrangements that accommodated equipment that hadn't existed when the Nevada was originally constructed. The crew quarters and internal arrangements received complete reconstruction that improved living conditions while maximizing the ship's combat effectiveness. The original berthing areas had been destroyed by fire and flooding, requiring design of new accommodations that reflected lessons learned from other warships about crew efficiency and battle damage control. The new arrangements provided better ventilation, improved sanitation facilities, and enhanced protection for personnel during combat operations. The Nevada's armament received significant upgrades that increased her anti-aircraft capabilities while maintaining her effectiveness against surface targets. Additional 40mm and 20mm guns were installed to provide defense against aerial attacks, while the main battery received improved fire control equipment that enhanced accuracy and rate of fire. The modifications required structural reinforcement throughout the ship to handle the increased weight and recoil forces of the additional weapons. The psychological impact of the Nevada's reconstruction extended throughout the Pearl Harbor workforce, providing tangible evidence that their efforts were producing results that exceeded pre-war capabilities. Workers could observe daily progress as the ship's superstructure grew upward from her reconstructed hull, each new section representing vindication of American industrial capacity and technical expertise. The Nevada became a symbol of resurrection that inspired workers facing similar challenges on other damaged vessels. Quality control during the reconstruction maintained standards that exceeded those of original construction, as inspectors recognized that the rebuilt Nevada would face combat stresses that had never been contemplated in peacetime naval architecture. Every weld was tested, every mechanical system was operated under load conditions, and every electrical circuit was verified to ensure that the reconstructed battleship would perform reliably under the extreme conditions of Pacific warfare. The Nevada's sea trials in May 1942 demonstrated capabilities that surpassed her original specifications, with improved stability, enhanced gunnery accuracy, and superior damage control systems that reflected the hard-won experience of American naval combat the early Pacific campaigns. The successful completion of her reconstruction proved that Pearl Harbor's workforce could accomplish engineering projects that rivaled the achievements of the largest commercial shipyards while operating under wartime constraints that would have paralyzed peacetime operations. When the Nevada departed Pearl Harbor for combat operations, she carried not only modern equipment and improved capabilities, but also the determination of the 2,847 workers who had invested their skills and endurance in her resurrection. Their signatures, carved into hidden sections of her superstructure, would accompany the ship through campaigns that would take her from the Aleutian Islands to the beaches of Normandy, proving that American industrial might could indeed transform defeat into victory through the systematic application of human skill and determination. Industrial accidents claimed the lives of 137 workers during the salvage operations, their names inscribed on a memorial plaque that most Pearl Harbor visitors never see. The human cost of Pearl Harbor's industrial resurrection remained largely hidden from the American public, as military censors suppressed information about workplace fatalities that might undermine morale or provide intelligence to enemy forces about the true challenges facing ship reconstruction efforts. The breakneck pace of salvage operations created working conditions that prioritized speed over safety, with supervisors under constant pressure to accelerate repair schedules regardless of risks to individual workers who had volunteered for assignments they knew could prove fatal. The most dangerous work involved removing unexploded Japanese ordnance from damaged ships, a task that required specialized knowledge that few Navy personnel possessed when the salvage operations began. Lieutenant Commander Draper Kaufman, who had studied bomb disposal techniques in England before the war, led teams that entered ship compartments where bombs had penetrated hull plating but failed to detonate. These weapons remained unstable for months after the attack, their fusing mechanisms corroded by seawater but still capable of exploding without warning if disturbed during cutting or welding operations. The ordnance disposal teams worked with primitive equipment that provided minimal protection against explosions that could vaporize several men simultaneously. The work required approaching each unexploded bomb with hand tools, carefully excavating around the weapon while avoiding any contact that might trigger delayed action fuses designed to explode weeks or months after impact. Several workers died when bombs detonated during removal operations, their deaths occurring so quickly that nearby personnel had no opportunity to provide assistance or even recover remains for burial. Industrial accidents multiplied as exhausted workers operated heavy machinery during 16-hour shifts that stretched human endurance beyond safe limits. Crane operators working 100 feet above the harbor surface struggled to maintain concentration while handling multi-ton hull sections that could crush workers below if dropped due to momentary lapses in attention. The cranes themselves operated beyond their design specifications, lifting loads that exceeded manufacturer recommendations while working in salt air that corroded cables and mechanical components at accelerated rates. The confined spaces within ship hulls created death traps where workers faced multiple hazards simultaneously. Welding operations in poorly ventilated compartments generated toxic gases that could cause unconsciousness or death within minutes, while the combination of oxygen and acetylene used for cutting created explosive mixtures that could ignite from sparks or static electricity. Several workers died from asphyxiation when they entered spaces where heavy gases had accumulated, their bodies discovered only when other crew members noticed their absence during shift changes. The magnitude defied comprehension. 137 worker fatalities during salvage operations from December 1941 through August 1945, 1,247 serious injuries requiring hospitalization for more than 30 days, 89 permanent disabilities, including amputations and blindness, and 23 workers who died from delayed effects of chemical exposure that wasn't recognized as hazardous until years later. The psychological casualties proved even more difficult to quantify, as military medical personnel had no framework for understanding the mental health consequences of sustained exposure to industrial death and destruction. Workers who had pulled bodies from sunken ships developed symptoms that would later be recognized as post-traumatic stress disorder, including insomnia, nightmares, and episodes of uncontrollable trembling that interfered with their ability to perform precision work. Many sought relief through alcohol consumption that became increasingly problematic as the stress of continuous operations accumulated over months of exposure to scenes that challenged their psychological resilience. Edward Raymer, the Navy diver, who had led teams into the Oklahoma's flooded compartments, struggled with recurring nightmares that featured the faces of sailors he had recovered from the ship's interior. His diving logs documented over 200 individual body recoveries, each one requiring him to handle human remains in conditions where decomposition was accelerated by tropical temperatures and contaminated water. Several members of his diving team requested transfers to other duties, but the specialized nature of their work made such reassignments impossible during the critical phases of salvage operations. The relentless work schedule contributed to domestic violence and family dissolution among workers whose personal relationships couldn't withstand the pressures of wartime industrial labor. Men who worked 16-hour shifts 6 days a week had limited time or energy for family responsibilities, leading to conflicts that were exacerbated by the isolation of military housing and the absence of normal community support systems. Several workers committed suicide, though these deaths were often attributed to industrial accidents to avoid stigmatizing their families or undermining workforce morale. Chemical exposure created health problems that wouldn't manifest for decades after the war ended, as workers routinely handled asbestos, lead paint, and industrial solvents without protective equipment that hadn't yet been developed for civilian use. The ship repair operations required removal of asbestos insulation from damaged compartments, exposing workers to fibers that would later cause lung cancer and mesothelioma in hundreds of individuals who had no awareness of the long-term health consequences of their wartime service. The medical facilities at Pearl Harbor were overwhelmed by industrial injuries that exceeded the capacity of military hospitals designed to treat combat casualties rather than workplace accidents. Crushed limbs from heavy machinery, severe burns from welding operations, and poisoning from toxic chemicals created patient loads that required evacuation to mainland hospitals when local resources proved inadequate. The transportation of critically injured workers to proper medical facilities was often delayed by military priorities that gave precedence to combat operations over industrial safety. Safety equipment remained primitive throughout much of the Reconstruction period, as manufacturers struggled to produce protective gear for industrial operations that exceeded peacetime experience. Hard hats were often improvised from steel helmets, while respiratory protection consisted of cloth masks that provided minimal filtration against toxic dusts and gases. Welding masks frequently failed to protect workers' eyes from ultraviolet radiation that caused permanent vision damage, while protective clothing was often unavailable for workers handling corrosive chemicals. The workers who died during Pearl Harbor's reconstruction were cemeteries with honors that recognized their contribution to the war effort, though their families received limited compensation compared to benefits provided to combat casualties. Their deaths were recorded in official documents that remained classified for decades, preventing public recognition of their sacrifice until long after the war had ended and most survivors had died of natural causes related to their advanced age. The memorial plaque honoring the industrial casualties of Pearl Harbor's reconstruction was installed in an obscure location away from the main visitor areas, reflecting continuing sensitivity about acknowledging the human cost of operations that had been portrayed to the American public as triumphant examples of industrial efficiency and patriotic determination. The names inscribed on the memorial represent only the documented fatalities, as incomplete record-keeping during wartime conditions likely resulted in undercounting of deaths that occurred among civilian contractors and local workers whose employment wasn't subject to military documentation requirements. The legacy of these industrial casualties extended beyond their immediate sacrifice to influence post-war development of workplace safety regulations and occupational health standards that were informed by the harsh lessons learned during wartime production. Their deaths contributed to understanding of industrial hazards that led to protective equipment requirements, safety training programs, and medical monitoring systems that prevented similar casualties in peacetime operations. The price paid at Pearl Harbor helped establish safety standards that protect the of workers in subsequent industrial operations throughout the remainder of the 20th century.